Welcome all the students. Today we are going to learn the topic architecture of raster scan display. In the last lecture we have learned what is meant by the raster scan display with the help of example, and now we are learning the architecture, or rather I say the block diagram of the raster scan system rather, or raster scan display. Let us start the discussion. See, if we are looking to this particular diagram first, okay, now we are considering this is the monitor screen where we are going to display the image or the picture. The picture is displayed on the monitor screen. Okay, but now if we consider it is in the form of the architecture diagram, okay, now we are considering that who is going to pass the information, okay, up to this monitor screen. So definitely we require the system bus. Okay, so the system bus is shown here, and all these IO devices are connected to the system bus. Okay, so all these input output devices, okay, we are considering the mouse, keyboard, monitor, okay, all these devices, okay, different devices are connected to the system bus. Okay, now through this system bus, okay, now as we have learned, whenever I want to display anything on this monitor screen, okay, in the form of the computer graphics, what is needed is I require the picture definition. Okay, and in the raster scan display, the picture definition, okay, is stored in the memory area, which we call it as the frame buffer. Okay, so we are considering this as the frame buffer. Okay, let me highlight it. Okay, we are considering this as the frame buffer is needed, or frame buffer always exists in the raster scan display architecture. In raster scan display architecture, frame buffer is there, which is going to store the picture information or picture definition. Where what is it going to store over here is it is going to store that the every pixel information or the value which is activated by what intensity or which color, that is stored. Okay, now here you can find in between this frame buffer where the picture definition is stored and the monitor screen where the picture is displayed, in between we are having something which is called as the video controller. Okay, so we are required to have a video controller here. Okay, so let us move to the first point. We have written an interactive raster graphics system. Okay, in interactive raster graphics system, in addition to CPU, obviously we are having the central process unit. Obviously the CPU is required in the block diagram. So in addition to the CPU, okay, we are having a special purpose processor. Okay, we are calling this as a special purpose processor, which is called the video controller. Okay, we are considering video controller is a special purpose processor in addition to the CPU, which is used to control the operation of display device. Okay, so display device, so whatever we are going to display, it is now controlled by the your video controller device. Okay, now what this video controller device does, this video controller accesses, or it is having the access to the frame buffer to refresh the screen. Okay, means it is going to access the contents of the frame buffer. Okay, rather I say it will, if it is in the digital form, it is going to convert it into the audio form, in the form of signal. Okay, and then it will be sent to the monitor. Okay, so the picture definition, reading the picture definition from the frame buffer or the image and passing it to the monitor screen, this is handled separately by a special purpose processor. So video control is a processor, special purpose processor, which is going to do this. Okay, now along with this video controller, in addition to this video controller, okay, we are required to have a display processor. Okay, so we are having to require a display processor which is going to handle all the activities of the graphics package, okay, or related to the graphics task. Okay, to do this means for monitor to related to display or the monitor, we require video controller. Okay, and to have related to the graphics task or the package, we required again a separate processor in the raster scan display. We call it as a display processor, and along with display processor, we are having the display processor memory. It is having its own memory, it is going to access along with the system memory. Okay, system memory and the CPU, we can say these are the part of our computer system. system bus IO devices. So additional thing which is we are having in the raster CAD display is display processor, its own memory, a frame buffer, and video controller. Okay, so I'm just moving to the next slide to continue with the discussion of display processor and related part. Okay, so we are continuing with architecture of raster CAN display. Now we will learn what is meant by the display processor. Okay, so as shown in the architecture diagram, just now we have seen this diagram. Okay, a raster system, it contains a separate display processor. This separate display processor is sometimes also referred as a display controller. Okay, we have seen video controller and now it is graphics controller. Okay, so display processor also referred as the graphics controller. Okay, so we call it as a graphics controller also. What is the purpose of this? The purpose of the display processor is to free the CPU from the graphics task. Okay, so I want that my CPU should not be always busy in the graphics task. So we use this display processor which will handle the graphics task or graphics related function. It will be handled separately by the display processor. That's why we are having this particular unit or this particular device. Okay, display processor, or we are also calling it as a graphics controller. Okay, now as we are having this graphics processor, it also requires some memory. Okay, where we can have access to this memory or it can read from that particular memory location. So that is the reason, in addition to system memory, okay, a separate display processor memory area is provided. Okay, so we are having one more area as display processor memory area, along with, in addition to the system memory is used, so that this display processor memory area can be accessible to the display processor. Okay, now the major task of this display processor, what exactly this display processor generally doing is, what its major task is digitizing a picture definition. Okay, so what it will do, it is going to digitize, a picture definition given in an application program. Means whatever is given in the application program or graphics package or graphics application. Okay, so what it is going to do is this display processor is going to digitize it into a picture definition, and once it is in picture definition, that picture definition is read, or it is in the form of the frame buffer, it is stored in frame buffer, and it is read by your video controller and it will send to the monitor. Okay, so video controller cannot read directly from the application program, okay, or graphics package directly. So that's why in between we are having the display processor. So it is going to digitize the picture definition given in the application program into a set of pixel intensity values. Okay, so it is going to convert, okay, this display processor is going to convert your graphics package or the application program into set of pixel intensity values, and it will be stored obviously through the display processor memory. It is stored in the frame buffer, and from frame buffer video controller is going to read it and send it to the monitor screen. Okay, in some of the cases, in some of the textbook, this process of digitizing a picture definition, I repeat again, the process of digitizing a picture definition, okay, is also known as scan conversion. Okay, so we can say the scan conversion is done by the display processor, okay, by taking the help of the display processor memory, and whatever the output it is going to generate, okay, that will be obviously the set of pixel with different intensity values that will be stored into the frame buffer, and from frame buffer it will be passed to the video controller, and so that the video controller is going to display it on the monitor screen. Okay, so I hope all of you understood. This is the simple architecture of the raster CAD display. In previous lecture, we have also learned what is the in between in detail what is meant by the raster scan system. Okay, so let us move to the next part or this particular point or the discussion. Now we have learned raster scan display. Okay, now we are going to learn what is meant by the random scan display. Okay, so I move to the next. So what we are going to learn now is we are going to focus on the random scan displays. Okay, raster scan displays are over. Now we are moving to the random scan displays. Okay, we are considering the random scan displays. Electron beam directed, okay, only to the part of the screen where the picture is to be drawn. Okay, what happens in raster scan? In raster scan, we are going to scan the complete screen line by line or one row at a time. That doesn't happen in the random scan display. That's why it is called as the random. Okay, it is not row by row or one scan at a time. Why it is random? Because the electron beam is directed only to the part of the screen where a picture is to be drawn. Okay, wherever the picture and wherever the pixel need to be activated, only at that area the electron beam is directed. Okay, so that's why it is called as random scan display. Random scan displays draw a picture. That's why we have call it as a one line at a time. Okay, so what it is going to do is it is going to draw the picture one line at a time. The same definition for raster scan, what we have said, it will draw the picture one row at a time, okay, by activating or scanning one row at a time or one scan line at a time. But here in random scan displays, it is going to draw the picture one line at a time, one line. And that's why it is also referred as, in different textbook, it is also referred as the vector displays, or as well as it is also known as calligraphic displays. Okay, so but normal way we are calling it as a random scan display. So the difference is, in raster scan display we are going to draw a picture by considering it as a one row at a time. Okay, one row or one scan line at a time. But here in random scan displays we are going to draw the picture one line at a time. Okay, this is also known as vector displays and calligraphic displays. Okay, now the component line of a picture can be drawn. So whatever the number of lines we are drawing, okay, this is called as, so line is considered as the component of the raster scan display picture, and it is refreshed by a random scan system in a specific order. Okay, so this obviously we know that we have to refresh the number of lines that we have drawn, okay, and it is carried by the random scan system. Okay, the refreshing of the same is carried by the random scan system. Okay, the best example of this random scan system, we call it as a pane plotter. Okay, so we are considering as the pane plotter, okay, is considered as the example of random scan system. It operates the similar way as random scan system, and it is one of the example of it. Okay, now in previous case we have seen that the complete picture, okay, in raster scan system, complete picture should be redrawn, okay, or refreshed or repeated. Okay, but here we can find the refresh rate of the random scan system. It depends upon the number of lines to be displayed. Okay, so I am having the less number of lines, there is no need to have so much higher refresh rate. Okay, so the refresh rate, whether it should be 30 times per second, maybe 60 times per second, okay, that will be depends upon the number of lines that we are displayed on the screen. We are going to display it on the screen. Okay, so this is what the major difference we are having between the raster scan display and random scan display. To understand this in detail, okay, let us, as we have seen one diagram for raster scan display, we are going to see the diagram for random scan display also. Okay, so let us look at this diagram, which we call it as the random scan display. Okay, so here it is, a random scan system draws the component lines of an object in an order specified. In here previously we have seen I have to draw this triangle. Okay, so if I want to draw this triangle on the screen in the raster scan display, what I have to do, I have to scan every line, every row one by one. I will start from this point and I will reach up to the end. Okay, but this is not happen in the random scan display. Okay, in the random scan display, my electron beam will start from one point. It is going to draw the one line. Okay, now it is very easy for me. Okay, in my random scan display, suppose I am drawing this triangle, I am having three lines. Okay, it is made up of the three lines. So in the first, when it is going to draw this first line, okay, I consider as one line it will draw. Then again it will draw the second line. Again it will draw the third line, and the picture is over. Okay, so that's why, means that is what the definition we have written. In the random scan display, the electron beam is directed only to the part of the picture which is available on the screen. Okay, so this is what the major difference raster scan display and random scan display. Okay, now as we have seen that I am moving this electron beam only to that particular part. I'm not scanning every row. I'm not scanning all the odd scan line, even scan line, something. Only I'm drawing the line directly. So obviously the speed of the random scan display will be higher. Okay, or it is having generally or the higher resolution. Okay, so continue with the discussion of the random scan display. I'm just moving to the next slide. This diagram clearly mentioned that how it is drawn. Directly I am moving the electron beam to that particular part. Okay, so it is not considered as a random. Okay, so random scan, not sequentially or not as per the raster scan line by line. Okay, so this is what the point. Now here, if I consider what is the picture definition for the random scan, so picture definition for the random scan is now stored as a set of line drawing commands. Okay, so picture definition is set of line drawing commands in an area of the memory referred as refresh display file. Okay, now in raster scan display we are calling it as a frame buffer. Okay, but here it is not called as a frame buffer. Here it is called as the display file. Okay, so we are generally using the word here as a in the random scan display is the display file. What it consists of? It consists of the set of line drawing commands. Okay, now this is the random scan display is specially designed for line drawing application. Okay, so for all line drawing application, generally we are using the random scan display. And maybe suppose you are using the AutoCAD where you are drawing so many different lines, you are going for the different application as where the line drawing applications are there. Okay, then we use the random scan display. At the same time, I have mentioned it is not suitable. Okay, I think underline the word not suitable for realistic shaded scenes. Okay, so whatever the movie picture, all these pictures that we are having or scenes we are having, or where we are having nature scenes, okay, or the realistic shades where realistic shades are required, okay, this is not suitable. Why it is not suitable? Because the picture definition is stored as a set of line drawing instruction and it is not set as the intensity values of all screen point which is required for realistic scenes. Okay, so for realistic scenes we should use raster scan display and we should use random scan display for line drawing application. Okay, for all different line drawing application we should use the random scan display. And I just now I have mentioned this particular point is generally this random scan display is having the higher resolution, okay, as well as I can say it is having the higher drawing speed. Okay, picture drawing speed is very high as compared to the raster scan display. Okay, so we can say these are the two advantages, having the higher resolution, having the higher speed of drawing as compared to the raster scan display. But one more drawback we can say or a demerit is they are not suitable for the realistic shades or realistic scenes. Okay, so this is what is meant by the random scan display. Okay, let us move to the, as we have learned the architecture of raster scan display, now we are also going to learn what is the architecture diagram or what is the architecture of random scan display. Okay, so I'm moving to the next point or next slide. Now we have seen the architecture diagram of raster scan display is very complicated. We have just now seen that particular diagram. It is having so many different components, so many elements. Okay, but I can say the architecture diagram of raster scan display is very simple. Okay, so obviously whatever I want to display it on the monitor screen is here. This is my monitor screen. Whatever I want to display, I'm having all the IO devices connected to the system bus. Okay, all these devices are connected to the system bus. Now here, okay, now I may not required a separate video controller which is there in the raster scan display. I not required the frame buffer, okay, which is there in the raster scan display. I may not require a separate memory for the display processor. All these things, all these different components are not there into the architecture of the random scan display. So that's why I say this is more simple as compared to the raster scan display. Okay, so this is the architecture of the simple random scan display is there. Okay, now which are the major component? So I am going to take the help of the central processing unit, my system bus, okay, and I am going to take the help of my system memory. Okay, so this is part of my system bus, system memory, and the CPU are always there in my computer or in my laptop or my machine. It is always available. So what is additional I required? So in the random scan display, in addition I required is my display processor. Okay, what is important part in my random scan display is my display processor. Okay, this display processor is important. Okay, So, and this display processor is going to process this, have access to this, and then it's sent to the monitor screen. Okay, so just read the 2 3 important point related to this architecture diagram. An application program is input. Because here whatever the input I am getting to draw it on the screen, I will get it from the application program, or I will get it from the graphics package, okay, as an input, and stored in the system memory. Okay, so whatever the picture definition or application I am getting, it is stored directly into the system memory. I am not going to use, I repeat again, I am not going to use a frame buffer. I am not going to use a separate display processor memory. Okay, it is directly stored, okay, into the system memory along with graphics package. Okay, next point, this graphics commands whichever is there with the help of the graphics package are translated into a display file. It is stored, that's why that is what I'm saying, in random scan display the picture definition is stored in a display file, but in the raster scan display it is stored in the frame buffer. Okay, so frame buffer word we are using for the raster scan. In random scan we are using, it is stored in the display file. All these line drawing commands are stored in the a display file, which is where it is stored in the system memory again. It is not required any separate memory, so it is stored into the system memory. Now this file is accessed by the display processor. So that is what I told. Only one important additional a component is there. A additional component is display processor. Okay, so we are considering this file is accessed by the display processor to refresh the screen. So display processor is going to access this file through the system bus. It is stored in the system memory. Through system bus it is going to access it, and it is going to send to the monitor, and as well as it is going to refresh it. Okay, now suppose I am having the, just now we have seen the example of triangle where I am having the 3 lines. So my display file is nothing but, my display file is having only 3 commands. One line which maybe I consider it as the a horizontal, then 2 diagonal lines are there. Suppose I consider this is my triangle. Okay, I want to display it on the screen. I'm just showing you here. So this is my one line, this is my second line, this is my third line that I want to display. Okay, so my display file in this case is having only 3 commands. Okay, 3 line command. Okay, suppose I'm drawing this is my first line, second line, third line. Okay, line number 1, line 2, line 3. Okay, so my display file is having only these 3 commands. What this display processor does, the display processor cycles through each command in display file, program once during every refresh cycle. Okay, means once this is over, again it is going to refresh it again by drawing the same line one by one. Okay, so it is going to cycle through each command in the display file program once during every refresh cycle. Every refresh cycle, in one refresh cycle it is going to draw all these 3 lines. Next refresh cycle again it is going to draw all these lines. Okay, and so on. Okay, so this is what, that's why I said speed of the random scan display. Okay, so whatever the drawing speed that we are talking about for the random scan display is higher, okay, as compared to the, okay, raster scan display. Okay, so I hope all of you will be very much clear with what is meant by the raster scan display and random scan display, and you also cleared with what is the difference between the architecture of raster scan display and architecture of random scan display. Okay, so this completes your, as per we consider it as a unit number 1. This completes your unit number 1. Okay, so in the next lecture we are going to continue with the unit number 2. Okay, so thank you very much.